Professional course in English. Process technology. Equipment and systems. Unit 9. Process diagrams. In this lecture you will learn types of process diagrams, basic instrument symbols, piping and valves, pumps and tanks, compressors, steam turbines, and motors, heat exchangers, furnaces and boilers, distillation columns, reactors. Sources of information for process technicians. Process diagrams are used to outline or explain the complex flows, equipment, instrumentation, electronics, that exist in a process unit. Types of process diagrams. Process flow diagrams. PFDs. Process and instrument drawings. P&IDs. Sometimes called piping and instrumentation drawings. Types of process diagrams. A flow diagram is a simple illustration that uses process symbols to describe the primary flow path through a unit. A process flow diagram provides a quick snapshot of the operating unit. Flow diagrams include all primary equipment and flows. A technician can use this document to trace the primary flow of chemicals through the unit. Secondary or minor flows are not included. Complex control loops and instrumentation are not included. The flow diagram is used for visitor information and new employee training. Figure 1 is a process flow diagram that shows the basic relationships and flow paths found in a process unit. A process and instrument drawing is more complex. The P&ID includes a graphic representation of the equipment, piping, and instrumentation. Modern process control can be clearly inserted into the drawing to provide a process technician with a complete picture of electronic and instrument systems. Process operators can look at their process and see how the engineering department has automated the unit. Pressure, temperature, flow, and level control loops are all included on the unit P&ID. A process and instrumentation drawing is a complex representation of the various units found in a plant. See Figure 2. Basic instrument symbols. The chemical processing industry has assigned a symbol for each type of valve, pump, compressor, steam turbine, heat exchanger, cooling tower, basic instrumentation, reactor, distillation column, furnace, and boiler. There are symbols to represent major and minor process lines and pneumatic, hydraulic, or electric lines, and there is a wide variety of electrical symbols. Piping and valves. Each plant will have a standardized file for its piping symbols. Process technicians should carefully review the piping symbols for major and minor flows, electric, pneumatic, capillary, and hydraulic elements. Future equipment. Piping and valves. The major flow path through a unit illustrates the critical areas a new technician should focus on. These include valves, strainers, filters, flanges, spool pieces, insulation, piping size, pressure rating, material codes, steam traps. Pumps and tanks. Pumps and tanks come in a variety of designs and shapes. Common pump and tank symbols are shown in Figure 5. Compressors, steam turbines, and motors. Because compressors and pumps share a common set of operating principles and are classified as dynamic or positive displacement, the symbols for compressors may closely resemble those for pumps. Modern P&IDs show the motor symbol connected to the driven equipment. This equipment may be a pump, compressor, mixer, or generator. Figure 6 illustrates the standardized symbols for compressors, steam turbines, and motors. Heat exchangers. The symbol for a heat exchanger clearly illustrates the flows through the device. It is important for a process technician to be able to recognize the shell inlet and outlet and the tube inlet and outlet flow paths. A heat exchanger with an arrow drawn through the body illustrates whether the tube side flow is being used to heat or cool the shell side fluid. The downward direction indicates heating. The upward direction illustrates cooling. Furnaces and boilers. If a proprietary process includes several types of equipment not typically found on a standard symbol file, the designer will draw the device as it visually appears in the unit. Distillation columns. Distillation columns come in two basic designs: plate and packed. Flow arrangements vary from process to process. The symbols allow the technician to identify primary and secondary flow paths. Reactors. Hydrocracking. Hydrodesulfurization. Reformer. Fluid catalytic cracking. Fluid coking. Tubular reactor. Fluidized reactor. Mixing reactor. Alkylation. Sources of information for process technicians. Information used by process technicians comes from a variety of sources. Some of these sources are operating training manuals, process descriptions, Process control manuals. Equipment summaries. Safety, health, and environment regulations. Operating procedures. Start-up and shutdown procedures. Emergency procedures. Process diagrams. Technical data books. Detailed equipment vendor information. To revise the learned material, answer the questions. What information is obtained from process flow diagrams? What information is obtained from process and instrument drawings? What sources of information process technicians use?